Okay, this is the third video of review for the air test using the PARC questions. Remember, PARC was sold their math questions to air, so some of these could show up on the air test. The first question here, we have two semicircles with centers P and M. The semicircles are tangent to each other at point B, and DE is tangent to both circles at points F and E. If PB is 6 and BC is 6, what is, and then it has a question mark, has four choices for us here, but it doesn't even tell us what that question mark happens to be, so who knows what this problem really wants. But what we know is PB is 6. We know that BC is 6, so from B to C is 6. Makes each one of these two parts 3. Other things that we would know in this picture, again, we don't know what their question is, so I'm just giving you some information. The distance from P to F, that would also be 6. And the distance from M to E would be 3. Using this information, they could come up with something else. Because this is a tangent and this is a this is a tangent and this is a radius, that's 90. This is 90, so we have two parallel lines. So we have two triangles that are similar. There's a bunch of different things they could do here. We can see that this is 3 to 6, so the side up here is half of the full side. So this side up here is going to be half of the full side. So since this is 3 plus 6 here, this needs to be a 6 out here to make it 9 and a total of 18. So they could be asking what DC is, but we don't know what they're asking. But that's just how you can fill out some of the information, and hopefully we would have something told to us as to what to find. But remember, all the radii are going to be the same. So since this was 6, this is 6. Add some different segments into your picture from time to time. On a question, I guess I want question 6. It's partway through here. Here we go. We have a figure that AC and PC, they intersect at point B. We're going to take images of these. In other words, we're going to dilate them with P as the center and a scale factor of 2. So P is going to be our center of dilation, and everything's going to be multiplied by 2. So use the choices in the drop-down menus. Since this is paper, the drop-down menu is shown to us here. So A prime, C prime, all right, will be parallel to AC. So if I take these and I actually do the dilation in this case, point B is a certain distance away. Say it's 3. B prime is going to be 2 times as far, so it's going to be 6 away. This distance is going to dilate out to here. It's going to turn out that it's going to be parallel. So A prime, C prime is going to drop down and become a distance farther away from P, but it's still going to be parallel to the original line. And P prime, Q prime, if I take this line and I dilate it, well, P is going to dilate onto itself because it's the point of dilation. And point Q, it is a distance of, call it 4. So Q prime is going to be down here at a distance that's maybe a total of 8. It's still on the same line. So that particular dilation is going to be the same line as the original. So having you think through what happens on a dilation. Points on a line are going to stay on that line if the line goes to the point of dilation. Points that are on a line that doesn't go through the point of dilation will be on a line that's parallel to it. Next, in question 7, we have this equation, x squared minus 8x plus y squared defines a circle on the xy coordinate plane. Select the choices from the drop-down menu below to complete the sentence. To find the center and origin, center of the circle and length of the radius, the equation can be rewritten as. Okay? See, our problem here is we really want it to be something like this. Or we have a phrase where we have y's in here and x's in here, equaling our radius. Because when it's in this form, we have an equation that is going to be centered at the values inside the parentheses and have a radius of whatever the square root of the number on the side is. So in this problem, what we're going to do is for my x's, this says minus 8x. We're going to take half of it. Half of minus 8 is negative 4. So first thing I'm going to do is take half of that negative 8. That gives me negative 4. My next step is to take that number and square it. Negative 4 squared is 16. So what I'm going to do is I'm going to put a 16 in here. So I'm going to have x squared minus 8x plus 16. That's a process called completing the square, because we have really created a square that is the same length on both sides. We've also made it so it can be written as x minus 4 squared. The number that I'm going to put in this position here is whatever number was half of that x term. So here, since it was minus 8x, half of minus 8x is minus 4. So our choice is going to be x minus 4 squared. Now our number on this other side, remember we still have the y squared in our original problem, and I have a 9. Now I changed the left side by adding 16 to the left side, so I have to add 16 to the right side, and 9 plus 16 gives me 25. When I had to add the 16 to complete the square, I had to balance that on the other side by adding 16 there. And 9 plus 16 makes it 25. So our circle would end up having a radius of 5. Looking at question 8, the table shows the appropriate measurements or approximate measurements of the Great Pyramid of Giza in Egypt and the Pyramid of Kukulkan in Mexico. Approximately, what is the difference between the volume of the Great Pyramid of Giza and the volume in Mexico? Okay, so we have their heights. We have the area of the base. So they're actually telling us the area of the base. You will be provided with a formula sheet that has your formulas for the various types of shapes. And for something that comes to a point, the formula for the volume, and this is a pyramid, it comes to a point, the formula is 1/3 times the base area times the height. All right. The capital B stands for the base area. Your formula sheet will tell you that as well. So for the pyramid in Giza, we're going to have to take 1/3 times the height and then times the base area. We would get some sort of answer out of this. We do the same thing for the pyramid in Mexico, 1/3 times the height times the base area. Let's see, this bottom one I can do pretty quick because 1/3 times 30 is 10. So I have 3,025 times 10. The pyramid in Mexico has a volume of 30,250. We'd have to use our calculator to find this other one. Let's see, that's 1/3 of 447 is 49. So I have 49 times 52,900. And I'm actually going to, I'm going to call that 50 and call this 50,000. Well, 50 times 50,000 would be 25 with 1, 2, 3, 4, 5 zeros. So that's 2,500,000. Take away 30,000 is going to be 2,470,000 roughly. So I'm somewhere in the neighborhood of 2,470,000 with an estimate. I'm going to say if we actually did the work out, it's going to turn out to be letter B when we subtract the two. Okay, the final question in this video is number 9. It says we have points A, B, C with these coordinates. And we can see what is the scale factor in the center of dilation that will carry ABC onto DEF. So what we're going to do is A has to go on to D, B has to go on to E, and C has to go on to F. So to find where our particular point of dilation is, go from A to D. Let me change the pen color so that's easier to see. Connect A to D, and that's dropping 3, go over 2. Drop 3 and go over 2 again, and maybe do it one more time. So the dilation line is somewhere on that red line that I have there. To get from A to D, I had to drop at 3 and go over 2. Drop at 3, go over 2. Repeat that a couple times. Now draw a dilation line for one of the other ones. To get from C to F, I had to go down 1, left 1. Down 1, left 1, down 1, left 1. The dilation point has to be somewhere on that line as well. Right now, we have a pretty good idea where the center of dilation is, don't we? It should be at the point 0, 0. And I can go one more further. To get from B to E, I go down 3, left 1, down 3, left 1, down 3, left 1. Notice all 3 went through the origin 0, 0. So you can find the point of dilation by connecting the points and then using that to extend the line. Where those lines intersect is your point of dilation. So in this case, this is 0, 0. Now, my dilation factors. Let me take my eraser and get rid of all this. Let's just look at point A. Point A was -4, 6. It dilated to D, which is -2, and it looks like it's up 3. What did I have to do? What did I multiply by to change -4 to -2? In other words, -4 times something gave me -2. What do I get when I solve that? Well, when I solve that, I divide by -4, so I get a positive 1/2. When we look at these two, the two y values, the question is 6 times something gives me 3. Well, b would be 3 over 6. b is 1/2. So both the x and y were multiplied by 1/2, so that dilation factor was 1/2. We can do that as long as we're talking about the origin as our point of dilation, our center. If it's not the center, it gets a little bit trickier. We have to kind of find out how these distances compare. But they'll probably keep the center of dilation there for a while. Next video, we'll pick up on question 10 and carry through parts of this. Notice this area is a calculator section. Those first questions on this handout were non-calculator. See you in the next video. Yeah.